Hey guys, so moving into Unit 1, Lesson 3, we're actually going to look at equations of a circle, which is not actually a function, but we can still write those equations and graph them by hand. So two basic concepts that you need in order to be able to do this is your midpoint formula. And remember, the midpoint of a segment, recalling your geometry, is the point that divides the segment into two equal segments. It splits it in exactly two. So like if M is the midpoint of CD, then CM is congruent to MD. Okay. So if point X is the midpoint of AB, the conclusion that you can then draw is that AX is equal to BX. All right, you can then also find the middle of a segment. So if I need to find the middle of AB, well, A is at 2, B is at 8, that's 10 split in 2, and the center is at 5. Right? So instead of sitting there and counting, just find your middle or your average like you would a mean. Same thing over here. A is at -8. B is at +5, so that's -3 divided by 2 is -1 1/2. So -1 1/2 would be about right there, would be your midpoint. Okay. But obviously we're not just looking at number lines here, we're looking at coordinate planes. And so if I want the midpoint of this diagonal line, I can't just count that. All right. But what you can see here is that you have a vertical change. So we're moving from a lower value to, or in this case, a higher value to a lower value. And then we have a horizontal shift as well. So we're moving across our board this way. So we can find the center of each of those lines, right? So the center of your vertical shift is right here because I was at, there's 2, 4. And then it goes from 4 to 2, and so the center of that will be right here at 3. That center is going to follow over to this blue line here. All right, and then you have your center of your horizontal shift. I'm starting at -1, and I'm going all the way over here to 3. So my center is then at 1 right here. And that center follows all the way up to right here. And so my center, or my midpoint of that line, is at 1, 3. And so essentially what I just did instead of counting was use my midpoint formula. You take both of your x's, add them together, divide by 2. That gave me my horizontal shift here. I had 3 plus -1 divided by 2. And then you take your y's and do the same thing, 4 plus 2 divided by 2, and that gives you your center point. Okay, so if you have endpoints at 7, -2, and -5, -2, you can easily find the coordinates of the midpoint by taking -5 plus 7 divided by 2, and then also -2 plus -2 divided by 2. And so your midpoint ends up being, well, that's 2 divided by 2 is 1. And that's -4 divided by 2 is -2. Okay. You can also work backwards from that. If you're given a midpoint, you can find another endpoint. And that's a little bit of algebra, or you can just kind of think of it in terms of your number line and where you'll end up. So for example, my x value, my endpoint is 2. I don't know my other endpoint, so we'll just call it x. Divided by 2, the middle where it will end up is just at 5. Okay, well, 2 times 5 is 10, so 2 plus x equals 10, so x equals 8. Another way to think of that is, again, think of the fact that you're starting at 2, you travel halfway and you end up at 5, right? If you travel the same distance, where will you end up on this side? Well, the gap between these is 3. So the gap between these will also be 3. And there, once again, we are at 8. Okay, so that's another way to kind of do it if midpoint formula itself confuses you. But we do the same thing for our y's. We have -3 plus y divided by 2 would end up at 8. So -3 plus y is 16. So y is at 19. You write that final answer as a coordinate, 8, 19. That's your other endpoint. All right. Midpoints are important to circles because the radius is the length of the distance, or the length, excuse me, from the center to the outside, and your center point is halfway across your diameter. And we're also using length. Again, radius is a length from the center to the outside. So to find the length of a segment in a coordinate plane, use the distance formula. Distance formula is d equals the square root of x1 minus x2 quantity squared plus y1 minus y2 quantity squared. All right, and this comes from Pythagorean theorem, which we'll look at. But given the two segments, we're going to tell whether or not they're congruent. So are they equal? This would tell you whether or not two circles were equal, if their diameter were the same or their radius were the same length. So you plug everything into distance formula here, and then you get the square root of, you have -3 squared is 9, 8 minus 2 is 6 squared is 36, 9 plus 36 is 45. For the purposes of this, I'm not going to reduce my radical. I'm just comparing two square roots, so there's no need. And then I go ahead and plug in the second one. So -2 minus 0 is -2 squared is 4. -2 minus -4, so that would be plus 4, is 6 squared is 36. So this equals the square root of 40. These are obviously not congruent. All right, so they're not the same. They wouldn't be the same size circle if we were dealing with that. Okay, so just looking at distance formula in terms of the actual circle, like I was saying earlier, we have this circle here, and I really meant to make XY right here and have your circle go through that, and this one got shifted when I formatted it, but so just kind of bear with me here on this slide. It's going to be a little sloppy. If we create a right triangle with the radius and the point on the circle, then you will see the shift horizontally. We're going from x to h, or from h to x. We're going to say x minus h. Right? The shift vertically, we're going from k to y, or y minus k. All right. When you think about Pythagorean theorem, a squared plus b squared equals c squared. This is side A and B, or B and A, it doesn't matter which one. And this is side C. Okay, so if we place everything in our Pythagorean theorem, then we get x minus h squared plus y minus k squared is equal to r squared. All right, well, look back at your distance formula. Here's an x. The second x value we called h. Here's a y. The second y value we called k. All right, this is exactly the same thing. Your distance is your radius. And if you square rooted both sides, you would get rid of this square and have that long square root symbol over the whole thing. So distance formula and this formula are the exact same thing. And this formula happens to be your equation of a circle. So r squared is equal to x minus h squared plus y minus k squared, or flip that around like we did up here. All right, the center is hk, the radius is r. So your center of your circle we denote as hk. We do the same thing for parabolas and their vertex, actually. Okay, so moving into graphing these real quick, if we can identify the center and the radius from our equation, we can sketch a graph from those. So here you have x squared plus y squared equals 25. Notice that we don't have a minus h or a minus k here, which means that hk, or your center, is just 0, 0. Right? If you're missing both or just one of them, that value is 0. R squared is 25, which means that my radius itself is the square root of that. So my radius is 5. When I go to graph that, and you're just going to do a really generic sketch here. My center again is at 0, 0. Because my radius is at 5, remember this is a distance from the center. And so I'm just going to count 5 in each direction from that. So 1, 2, 3, 4, 5. Remember, you can't count diagonally, so I'm just going to go each direction. 4, 5. You don't always start at the origin. I'm starting there because that's my center. And so I go and I make these 4 points. Then connect them as close to a circle as possible. As long as you don't make a diamond shape, I'm not going to like scoff at it being unsymmetrical or anything like that. Okay? All right, moving on. Second one. Go ahead and I'm just going to pop this answer up here. Okay, so watch your signs when you do your center. We're at 2, -1. That's the only thing that would make this a plus, is if we switch the sign. Square root of 16 is 4. So from my center point here at 2, -1, I'm going to go 4 to the left, 4 down, 4 to the right, and 4 up. Draw your circle, and you got it. All right, now switching up to actually writing the equation. Find an equation of a circle with a radius of 3 and a center at 2, -5. Remember that this is h and k. This is your r. So you're going to have r squared is equal to x minus h squared plus y minus k squared. Or flip that around. Again, it doesn't really matter. So 3 squared goes in. Then you have x minus 2 squared plus y minus -5. And you should be able to skip this step. Oops, I put my squared in the wrong spot there. Sorry about that. And then just simplify. So 9 equals x minus 2, y plus 5. And there's your center and your radius and your equation. Now, sometimes you have to find the equation. So find an equation of a circle that has points at 1, 8 and 5, -6 as the endpoints of the diameter. So if you were to draw this circle, your endpoints would be at those 2 points there. Obviously, not to scale here. Okay, so that being said, keep in mind, remember your center is the midpoint, and this radius here we can find by using distance formula. So we need to do both of those. Okay, so the first thing we do is find the midpoint of those 2 points. So go ahead and do that. Okay, so your center point is at 3, 1. And then we want to find the length of the radius. You can do this 2 ways. You can use your distance formula with your original 2 points and then divide it by 2. Or you can just pick a point and use your center, which is what I would recommend. Then you don't have to remember to divide by 2. We're going to use our distance formula. And I'm just going to use point P to keep it all positive, so it doesn't really matter. Okay, plug that in and solve it out. So your radius then is the square root of 53. There's no reason to actually take that square root because remember that your equation has r squared in it. And so those actually will end up canceling out. So we have x minus h quantity squared plus y minus k quantity squared is equal to r squared. We're going to leave that r in radical form so that when we plug it out, it works out nicely. So we get x minus, your h value was 3, quantity squared, plus y minus, your k value is 1, equals the square root of 53 squared. And so your last step there is just to simplify that. We get x minus 3 plus y minus 1 equals 53. Okay. All right, one more here. You can see, obviously, this one looks a little bit different. I'm going to go ahead and rewrite this so that my like terms are together. So we have x squared minus 2x plus y squared plus 4y. And I'm going to set this equal to -1. So any constants that you have move. And hopefully you can kind of see up here where we're going with this. We want x minus a number quantity squared, y minus a number quantity squared. So we want perfect square trinomials that factor like that. Recall back to last unit, the way that we are able to do this was by completing the square. So we get x squared minus 2x plus a c value. And then we're going to do y squared plus 4y plus a c value over here. This will then help us to rewrite it in such a way. So we'll have to then add both of those numbers on this side as well. Okay, so completing the square, remember you get b divided by 2 and square it. So b divided by 2 squared is what we're going to add on to these equations. So we're going to do this twice. So -2 divided by 2 is -1, squared is 1. So we didn't actually need to add that 1 over. We could have grouped it with the x's. I didn't know that, so it's still faster to do it that way. But we're going to add that 1 to the other side of our equation here. And then we do 4 divided by 2. And switch colors there, but we square it. So 2 divided by 2 is 2, or excuse me, 4 divided by 2 is 2, squared is 4. So we're going to also add 4 to both sides. All right, now both of those will factor. So this breaks out into x minus 1 quantity squared. We got the minus from here. Remember, this is just b divided by 2 that goes in here. Plus y plus 2 quantity squared is equal to, those ones cancel, and it's equal to 4. So your center is at 1, -2, and your radius is the square root of 4, which is 2. This next part is quite a bit of writing, so I'm going to walk you through it and then just kind of pause the video so you have a chance to catch up. But symmetry and how to test for it. So when we're looking for symmetry of a equation, not necessarily even a function, that obviously applies to circles because they are symmetrical, but it applies to all of your equations. So if the point xy is on the graph then we can replace the y by -y. The resulting equation is the same as the original, then it will have symmetry across the x-axis. You'll also be able to graph x, negative y, okay? So both of these points would be on your graph. And again, we can determine that by taking our regular equation, replacing the y by a negative y, and solving that out. It should be the exact same as the original. To test for symmetry across the y-axis, it should have both the point xy and negative xy on the graph. So to do that, we're going to replace the x by negative x. The resulting equation is the same as the original. All right, keep in mind we're simplifying and seeing if these are the same as the original. Then it is symmetrical across the y-axis. To see if it has symmetry across the origin, then we can graph both xy and negative x, negative y, and see if it is the same as the original. So replace the x by negative x and the y by negative y. And see if it is the same. All right, so go ahead and pause the video and get those definitions down, and then we will move on. Okay, so here's a chance to kind of see what I mean by this. So we're going to test this for symmetry. So the first thing we're going to do is test it for x-axis symmetry. Recall that to test it for x-axis symmetry, you're going to replace the y with a negative y. And so we have negative y is equal to x cubed minus 9x. Solving for y, here we get y equals negative x cubed plus 9x. This doesn't simplify any further, so it is not symmetric to the x-axis. To test for y-axis symmetry, we plug in for the x value. So y equals negative x cubed, minus, I'm ahead of myself here, negative x times 9. All right, so if I cube a negative x, I end up with a negative x cubed because negative 1 cubed is still negative. And then negative times negative here is positive, so this is not the same as the original, so this is also not symmetric. And then last, we're going to replace both. So negative y is equal to negative x cubed minus 9 times negative x. To replace both the x's and the y's here and simplify that out. So we get negative y is equal to negative x cubed plus 9x. That comes from right here. And then we need to divide off that negative sign. So divide everything by negative 1. And we get y equals x cubed minus 9x. This is the same as what we started with. And so this is symmetric to the origin. Right, and that's how you test for symmetry. Go ahead and try this second one on your own. Okay, hopefully you saw here that this one is symmetric to all three, the x-axis, y-axis, and origin. That has to do with how squares affect numbers when you square them. So they always turn out even, or positive, excuse me. All right, and that's it for lesson 3. Let me know if you have any questions, and have a good day.